Some more limit questions then here in question 8. We have a function which has absolute values in it. And this is kind of interesting that over here I have a form of 1, but that form of 1 is not defined when x equals 7. So I can simplify f of x right away by saying that f of x is going to be absolute value x minus 7 over the absolute value, not absolute value, just the quantity x minus 7 plus 1. And just to emphasize, x cannot equal 7. Now, further, I can say that the absolute value part I can write as a piecewise defined function, remembering that the absolute value of x minus 7 is just going to equal x minus 7 when x minus 7 is positive. But then I'll have to take the opposite of it if it's negative. So that gives us an even simpler question, or a simpler function, if we make it a piecewise defined function. So this would say that f of x is going to equal, well, x minus 7 over itself, x minus 7, if x is greater than 7. Now note, it can't equal 7 because I have x minus 7 in the denominator. And the function f of x will be the opposite of x minus 7, so a negative sign out in front of it, over x minus 7 if x is less than 7. And what am I forgetting? Let me put in a different color. There's still the plus 1. So plus 1. Plus 1. I can clean up a little bit here. Plus 1. If x is less than 7. Well, that simplifies even further. I get this very simple piecewise defined function. When x is greater than 7, I'm going to have 1 plus 1. I'll have 2. F of x equals 2 if x is to the right of 7. And then here I'll have negative 1 plus 1, 0, if x is to the left of 7, less than 7. So now, once I've done all of that simplification, the rest of the question should be fairly simple. The limit as x approaches 7 from the right, meaning x is greater than 7, is going to be 2. The limit as x approaches 7 does not exist because the left limit is going to be different from the right limit. In fact, the left limit is going to be 0. So really, after we do all the algebraic simplifications, evaluating the limits was the easy part. And in our last question, we're looking at a position or displacement versus time graph of two people running a race. And there are some issues with my graph that are there on purpose. So one thing that people should take issue with is that after I spent all that time on my previous video talking about making good graphs, I did not put any arrows here. I did label them. But I didn't put a scale on the displacement on the vertical axis, and I did that on purpose. Well, let's answer the first two questions. When was Mr. Brown winning the race? Well, he'd be winning the race when in the same time he has covered a greater distance. So Mr. Brown well, it wasn't, you can't say he's winning when they're at the same place, right? So not at 0, but in time is between 0 and 4. Mr. Brown has the lead. Mr. Red is a slow starter, but then he starts to accelerate. And so at t equals 1, here, now let's look at this question. Who is running faster? Not who is winning, but who is running faster at t equals 1 and t equals 4? So what I want to think about is, if I estimate what the rate of change is, so we're looking at what is the velocity at t equals 1 for each of the runners. Well, I can't calculate that exactly for Mr. Red, but I can certainly see that his graph is not as steep as the graph for Mr. Brown. And in fact, I could, if I knew the units for position, I could actually calculate Mr. Brown's rate of change because it's constant. It would just be the slope of this line segment. But what I can say is that since that part is steeper, at t equals 1, Mr. Brown was running faster. Now at t equals 4, which graph is steeper? Well, the red graph is much steeper than the brown graph. So Mr. Red was running faster. Okay, at part C now. Which runner fell during the race and picked himself up to continue? Well, when he fell, he was completely stopped. And so this would be Mr. Brown from 3 to about 3.5 seconds. He is no longer moving there. So Mr. Brown fell. And then D, the runner who fell, that's Mr. Brown, filed a protest claiming the other runner tripped him. Does the claim have any merit? Well, I left this ambiguous on purpose and because I would just like to understand people's line of reasoning. So on the one hand, so Mr. Red was behind Mr. Brown when he fell. So if he is behind, doesn't look like that he would have an opportunity to trip him. However, since we do not have a scale on the vertical axis, it is possible that he was close enough to trip Mr. Brown. So there's no one correct answer here. Either one of those answers would have been acceptable. I just wanted for you to analyze the situation given the information and see if you noticed that we didn't have a scale, and so that we really can't answer the question. We can't determine it without that information. Well, I hope that this will be a good help for you in preparing for our first test. And if you have any questions about any of these solutions, then please feel free to contact me.